Okay, we're going to continue our conversation about moles and talk about molar mass with the subtitle, How do we determine the number of moles in a substance? Now that we know what a mole is, how are we going to use it? Now, I know you just started listening to this video, but I would recommend that at this point you pause and root around in your backpack until you find your periodic table, because it would be a good idea to have that sitting open next to you when you're going through this particular lecture. So find that and have it so that you can look at it. I'll wait. And that's probably long enough. Okay, so let's move on. As we said before, the atom is small. So how can we find out the number of atoms in a sample? Well, this time I'm talking about the specific sample of some kind of compound. How do we determine the mass of a very small sample? Well, we use this concept of molar mass, and a molar mass is a general expression used to refer to the mass of a mole of a substance. The units for molar mass are grams over mole. So in other words, this is the number of grams that a mole of something weighs. Now, in the last slide deck, in the last lecture, we were talking a lot about how a mole is a number. It's just a certain number of things. You can count atoms, or you can count ions, or you can count stools, or you can count grains of sand with a mole, because it's just a number. But I don't want you to get confused with this concept. The molar mass of all things will be different. From each element will be different based on the characteristics of that element, but the number of atoms of an element that make up a mole is always the same. The number of anything that makes up a mole is always 6.02 times 10 to the 23rd. So just don't get confused with that part there. Okay, so the molar mass for a compound, which is specific for a given compound or element, will be measured in grams per mole. Let's see how this plays out. We want to now think of the periodic table in reference to one mole rather than to a single atom. And so if you look at your periodic table, and for each box for a given element, hydrogen or carbon or whatever, there's an atomic mass in there. All right, and we've used that atomic mass before. You've looked it up before. You know that carbon is 12.0 something, whatever. Hydrogen is 1, helium is 4. Okay, so those are atomic masses. Now I want you to think of those numbers differently. Now I want you to think those atomic masses as the mass per mole. All right, so that number, when you read it off the table now, is the grams per mole for a compound and not just the atomic mass. It can be used both ways. So let's see a little bit of an example. What's the molar mass of strontium to the nearest tenth? And in fact, in general, let me say this now, and I'll bring it up again later. When you read a number off the periodic table, when you read a mass off the periodic table in our class, I always want you to round it off to the nearest tenth, to the first decimal place. All right, that's just going to be the general rule. Okay, so you look on the periodic table and you find strontium, and you look at the atomic mass. What is it? It should be 87.62. Of course, you're going to round that off to the nearest tenth, so you get 87.6. All right. Now, since we're talking about the molar mass and not the atomic mass, the units are different. They're not AMUs like we've been talking about before. They are now grams per mole. So we add the units of G over mole to 87.6 to get the molar mass for strontium of 87.6 grams per mole. All right. So if you needed to obtain 1 mole of strontium, you would need to weigh out 87.6 grams of strontium. That's how many grams of strontium it takes to make 1 mole of strontium atoms. Well, that's all fine and well for elements. What about compounds? Remember, a chemical formula, like H2O, tells us the atoms that make up 1 molecule or 1 formula unit if it's an ionic compound. All right, the number of atoms that make up a molecule. So let's look, for example, at calcium sulfate, CaSO4. CaSO4 is made up of 1 atom of calcium, 1 atom of sulfur, and 4 atoms of oxygen held together in a specific way to make a formula unit, or yes, a formula unit of calcium sulfate. All right, this is review. We've had this before. We know this. Now, that formula can also be used to determine the amounts of moles. So, with 1 mole of calcium sulfate, and remember, 1 mole of calcium sulfate is how many formula units? 6.02 times 10 to the 23rd. If you had 1 mole of calcium sulfate, you will find 1 mole of calcium atoms, right? And 1 mole of sulfur atoms, right? And how many moles of oxygen atoms do you think? If you said 4, you are correct. So the subscripts in the formula tell you the number of moles that you have of each element. So calcium sulfate is made up of a mole of calcium atoms, a mole of sulfur atoms, and 4 moles of oxygen atoms. So now we can determine the molar mass for calcium sulfate just like we did for strontium a couple minutes ago. Oops, okay, jumped ahead there. All right, we know that there is 1 mole of calcium in a mole of calcium sulfate, and you can look on your table to see, on your periodic table, to see that the molar mass for calcium is 40.1 grams per mole. 1 mole times 40.1 grams per mole gives you 40.1 grams. We also know that in calcium sulfate, there is 1 mole of sulfur atoms. 1 mole times 32.1 grams per mole. Wait, where did this come from? Off the periodic table, that's right. So you look for sulfur, you'll see that its mass is 32.1 grams per mole, times 1 mole gives you 32.1 grams. Here's the interesting one. Oxygen, if you look at its mass on the table, it's 16 grams per mole, but we have 4 moles in our mole of calcium sulfate, so 4 times 16 is 64. All right, so now we're going to add these things together to come up with 136.2 grams per mole as the molar mass for calcium sulfate. You can do any other compounds the same way, and in fact, we're going to practice those next. All right, so your turn. What is the molar mass of carbon dioxide? To answer that, you look at what makes up carbon dioxide. It's 1 carbon and 2 oxygens. So you look at your periodic table and you find the mass of carbon, and then you find the mass of oxygen. All right? And then the formula tells you there's 1 carbon and 2 oxygens. So you're going to add the mass for carbon plus 2 times the mass for oxygen. You should get 44 grams per mole. How about sodium chloride? Well, same process. You're going to need to look up the mass of sodium and the mass for chlorine, and the formula tells you that there's 1 sodium and 1 chlorine, so you'll simply add those 2 numbers together and you should get 58.5 grams per mole. What about barium chloride? Slightly more interesting. Same process. You're going to need the mass for barium and the mass for chlorine. The formula tells you there's 1 barium and 2 chlorines, so you'll add together the mass of 1 barium and 2 times the mass of chlorine, which should give you 208.3 grams per mole. That is the molar mass of barium chloride. And that's the end of our program for today. Now, tomorrow in class, you're going to be working on your megamole worksheet. Please make sure you print that out and bring it. You will need it in class tomorrow. I will see you on Monday.